All right, guys, welcome back. We're going to continue with quadratics, of course. And today, though, I think we're going to really start to see things come together. We're going to use factoring method to solve quadratic equations. Now, before we get into the actual quadratic equation, I just wanted to talk to you and show you some similarities and differences between a linear function and a quadratic function. So kind of we're going back in time a little bit. It's kind of like a little mini review already for you guys for linear equations. We know that linear functions or equations, bless you, are in the form of y equals mx plus b, where y is the dependent variable and x is the independent variable. M is the slope, which remember the slope formula is y2 minus y1 over x2 minus x1. And b is the y-intercept. We've been working a lot with this y-intercept. What is the definition of a y-intercept? It is the y value when x is 0. Good job, son. Notice also, gentlemen, what is the exponent of x here? 1. It's invisible. It's 1. So please notice that the degree of the polynomial is 1. So that means that when the degree is 1, it is a linear function. Linear functions render straight lines, such as the 4 lines that I have here. I have this red line with a slope that is equal to, what's the slope of a vertical line, guys? It's undefined. It's undefined. And this comes from an x equals a equation. So this red line right here will be 1, 2, 3, 4, 5. This would be x equals negative 6. We've gone over this, guys. What is the slope of this green line? 0. Very good. And that's a y equals equation. So the equation here would be 1, 2, 3, 4, 5. Y equals 6. Remember that this blue line is a negative slope. And to get the slope of a line, you find 2 perfect points. Okay, 2 perfect points. Probably could have found one. Actually, this one would be easier. I'm going down 1, 2, 3 over 1, 2. So that would be negative 3 halves. Or you could get the coordinates here for x1, y1, and x2, y2, plug it into the formula. And of course, my black line is a positive slope. Okay? So those are the 4 different types of slopes you can have. That's what linear functions are going to give you, straight lines. When we're talking about solutions, because that's what we're talking about today with quadratics and whatnot, solutions. When we're talking about solutions of a linear equation, my friends, every single point that makes the equation true is a solution. So in this particular case, every single point that is actually on this black line, guys, is a solution. Every single point on the green line is a solution. Every single point on the blue line is a solution. Okay? So points that make the equation true, ordered pairs that make the equation true, are solutions. As far as systems of equations go, guys, the solution of a system of equation is the point that makes both equations true. And if you guys remember, we learned how to solve systems by graphing, substitution, elimination. The solution is, boom, right there. The intersection point of 2 lines. So we just had a little mini review of what the y was, the x was, the y-intercept, the m, which is the slope, the 4 different types of slope, and also how to find solutions. Pretty good. Now let's transfer that to quadratics. Let's see how we relate it. I have y equals ax squared plus bx plus c. Here the y is still dependent, guys. The y is always dependent. Here the x is independent. The x is always going to be the independent variable. A and b are coefficients. Okay, let's talk about this. What can you tell from a in a quadratic equation, guys? What can you tell from a? Yes, sir. Okay, if there's going to be a minimum or maximum. Thank you, sir. How do you know if there's going to be a minimum, son? Sorry about the bell. Sorry about the bell. Go ahead, sir. Yeah, if it's positive. If A is positive, it's going to go like this, and you're going to have a minimum. What happens if A is negative? It points downwards, and I'm going to have a maximum, right? That's what we know about the A already. What else do we know about the A related to the width or the narrowness of the graph? Yes, sir. If the absolute value is between 0 and 1, it's going to get wider and wider. The smaller the absolute value between 0 and 1, the wider it gets. And the larger the absolute value of A, the narrower or thinner that it gets. Perfect, perfect. We know also that the C is the y-intercept, and again, that's the y value when x equals 0. Notice that the degree of this polynomial is a 2. That's why it's called quadratic. Quadratic functions render parabolas, such as the two that I have here. When you look at this parabola, though, now, guys, you should see a couple things. First of all, for this first graph, was the A positive or negative here? It was positive for sure because it's pointing up. I have my solutions right here, because remember the x-intercepts are the solutions. This is my vertex right here. I have an axis of symmetry going through that. And this guy right here is my y-intercept, the y value on the y-axis when x is 0. If I look at this other graph, what was the A here? Was it positive or negative? It was negative. It was less than 0 because it's pointing downwards. I still have a vertex. My axis of symmetry goes through that vertex. In this case, I have my solution of -6 and 4 because the x-intercepts are the solutions. And I have my y-intercept right here with its mirror image over there. But the y-intercept is the y value on the y-axis when x is 0. The points at which the parabola crosses the x-axis, which we already discussed, are the solutions of the quadratic function. In other words, the x-intercepts are the solutions of the quadratic function. These guys right here, the x-intercepts, those are the solutions. Does that make sense, gentlemen? All right. Sometimes we can find solutions of the quadratic function, guys, by factoring. And then once we factor it, we can use what's called the zero product property. The zero product property is a very powerful property which states that for any real number, A and B, okay, if A times B equals 0, then A has to equal 0 or B has to equal 0. Why, Moro? Well, if I have 5 times x equals 0, doesn't x have to be 0 because anything times 0 equals 0? That's the concept here. Whenever I have 2, 3, 4, 5, 20 things being multiplied together, if that product is 0, I have to set each individual factor equal to 0 and find what that value is. So if I told you, for example, if x plus 3 times x plus 2 equals 0, then since this is a zero product property, I must set x plus 3 equal to 0, and I must set x plus 2 equal to 0. And then I solve. Subtract 3 to both sides, so x would equal -3, and also it will equal -2. It will have 2 different solutions. Does that make sense? So, what I'm going to practice with you now is not the real part of this. This is just a part of the zero product property that I want you to practice before we start factoring, okay? They're rarely going to be this easy. I want to know what are the solutions of the equation, and they give us 4x plus 1 times x minus 2. Well, this is your A value. This is your B value. If A times B equals 0, don't I have to set A equal to 0 and B equal to 0? Does everyone see that, gentlemen? Everyone, do you see that? Okay, so now solve for x. Subtract 1 to both sides. 4x equals -1 divided by 4. So one possible solution is -1/4. Then I add 2 to both sides. X also equals 2. So my solution is x equals negative 1, 4th, comma 2. Danger. Do not do this. Why would that be wrong? Thank you, son. This is an ordered pair. Are the solutions an ordered pair? No. They're individual solutions. Great job, kid. Does that make sense so far, guys? Yeah. All right, let's practice some more just zero product property stuff. What are the solutions of each equation? Well, you have x plus 1 times x minus 5 equals 0. So you got to set x plus 1 equal to 0 and x minus 5 equal to 0. And x is going to equal negative 1 and comma positive 5. Some of you are looking at me like, how did I do that? I just solved for x, guys. Come on, man. It's a single step equation. We got a final in a few weeks, so these are all skills you should know. Number 2. What are the solutions to this equation? I got to set 2x plus 1 equal to 0 and x plus 14 equal to 0. So subtract 1 to both sides. 2x equals negative 1 divided by 2. So x is going to equal negative 1/2. And subtract 14 to both sides. X is also going to equal negative 14. So my solutions are negative 1/2 comma negative 14. Those are my solutions. 7n minus 2 times 5n minus 4. Well, set 7n minus 2 equal to 0 and set 5n minus 4 equal to 0. So what will n equal here, guys? 2 7s and excellent 4/5. Good. Last but not least, 2x plus 3 times x minus 4 equals 0. So you set 2x plus 3 equal to 0, and you set x minus 4 equal to 0. So what will x equal? Negative 3/2 and positive 4. Okay. Does that make sense, brothers? That's the zero product property. Okay? Now, let's put it all together. What are the solutions of each equation? Okay. Check it out, guys. Is it telling you to graph? So do I have to find the axis and the vertex and all that stuff? No. It just says what are the solutions. We've done this before. This is factoring. So let's factor. 1 times what is 15, but when added together is 8. Positive 5 and positive 3. Hey, look at that. Now don't I have a zero product property here? So now I go x plus 5 must equal 0, and x plus 3 must equal 0. So x equals negative 5 and negative 3. Does that make sense to everyone? Okay, write that down real quick, because I'm going to show you how you would do this now properly by graphing and not having to have any estimated values. Remember that yesterday when we were doing the homework, I said when you're graphing it, guys, until further notice, you're going to estimate those solutions, right? All of that can end today. Are you ready? All right, let me show you what to do. If I tell you, solve by graphing. If I don't say solve by graphing, you could do it just like we did. Factor it, solve it, you're done. Okay? But if I say solve by graphing, check it out. Number 1, my axis. Negative b over 2a, so it's going to be x equals negative 4. 2, my vertex. My vertex is negative 4, comma, negative 4 squared is 16, minus 32 is negative 16, plus 15 is negative 1. Step 3, my y-intercept is 0, 15. Now, step 4, my x-intercepts. At this point, you factor, just like we did. X plus 5, x minus 3. Because what is the x-intercept, guys? Isn't the x-intercept the x value when y is 0? So solve. So x is going to equal negative 5 and 3, correct? So my x-intercepts are negative 5 and 3. Now, this is where the magic happens. And I know I'm a bit of a math dork, but it's like magic for me. Okay. My axis of symmetry is -4. 1, 2, 3. My vertex, -4, -1. My y-intercept, let's just say, guys, that this is 11, 12, 13, 14, 15. Yes? Come again? Come again? Oh, because this is x plus, yes. Okay. So, my y-intercept is 0, 15, so that's up here. That is 1, 2, 3, 4 to the right, so you got to go 1, 2, 3, 4 to the left. Are you with me? And now, what are my x-intercepts? -5, -3. Is there any necessity to have to round anything now? That's the point of all of this, guys. Now, if I just say solve, do you have to graph it? No. But if I say solve by graphing now, you have a tool to find the exact x-intercepts. Because that's the whole point of all of this jazz. The whole point of the quadratic formula and the quadratic functions and graphing, where are the x-intercepts? That's the goal. Yes, sir, my brother. Okay, why would you graph on the quiz tomorrow when I just said you don't have to graph unless I say graph? If you have to graph, I just said do it that way. Yes, of course. Does that make sense, everybody? Okay. I'm going to erase this, okay? Yes? Okay. I know we're not going to graph anymore. I just want to be a good teacher and show you what it is exactly that you're doing here. Because there's nothing worse than doing procedures and not knowing why. I think that's horrible, in my opinion. So now, guys, I'm sorry, but I'm going to have to fly because I've only got like 13 minutes. So I'm going to fly, but I promise I will talk to you through my thought process. Okay, I got m and an m. What times what is -14, but I have to get this -5? Excellent. -7 and 2 equals 0. Zero product property, so m is going to equal 7 and -2. Got to set each of these equal to 0 and solve. Number 3, what times what is -20, but when added together is 1? What times what is -20, but when added together is 1? There's a 1 in front of that p. +5, -4. So p equals, what are my solutions? -5 and 4. Last but not least. Oh, Cuban method or table method? I'm going to do the Cuban method. If you like the column method, do it. So, 2x, 2x. 2 times 18 is 36. What times what is 36, but when added together is -15. -12 and -3, very good. Artificial factor, so I got x minus 6 times 2x minus 3 equals 0. Set both x minus 6 equal to 0 and 2x minus 3 equal to 0. What do I have left? X equals 6 and 3/2. Fantastic. Fantastic. We got one more page, but does that make sense so far? Actually, 2 more pages. You ready? Because I got to fly. Okay. Now, I have one more after that. Okay. So first of all, what do I do with this 18? I got to subtract 18 to both sides. Yes, guys. Because I got to set this equal to 0. So I got 4x squared minus 21x minus 18 equals 0. You know me, I like my Cuban method. So I'm going to go 4x. If you want to do it the column method, God bless you, you can. 4 times -18 is -72. What times what is -72, but when added together is -21? I can't wait forever. -24 and +3. Artificial factor of 4, so I'm going to get x minus 6 times 4x plus 3. You set both of those equal to 0. What will my x equal? 6, and negative 3/4. Excellent. Thank you. Thank you. Thank you. Number 2. What times what is negative 54, but when added together is 3? Positive 9 and negative 6. Come on, guys. Got to set both of these equal to 0. So what are my solutions? X equals negative 9 and... Now remember, just for giggles, you know this is a positive graph, right? If I wanted to, in a nutshell, I could make a sketch of the graph. Not an official graph, but the sketch of the graph, I know I have a 6, I know I have a negative 9, and I know it's going through it like that. That's the beauty of this. You know it's going up already, and you know it's going through these two x-intercepts. Does that make sense? But that's not very accurate because you don't have the axis, you don't have the vertex. That's just a sketch of the graph. Does that make sense? I just want you to continue seeing exactly what it is you're solving for. What are these stupid x's? These x's are the solutions of the graph. Last but not least, for this, I got 2x and 2x. 2 times negative 36 is negative 72. We already did this one. What times what is negative 7? Didn't we do this one?
No, we did with 4x.
Oh, okay. Thank you, guys. What times what is negative 72 but not together is negative 21? That we did already. Negative 24 and 3. Artificial factor of 2. So I got x minus 12 times 2x plus 3 equals 0. What are my solutions? 12 comma negative 3/2. Does that make sense, my brothers?
Yeah.
We promise. Yes, sir. Number 3, sorry. What do I got to do with this negative 49 first? Add 49 to both sides. Thank you, son. So I got x squared plus 14x plus 49. Does anyone recognize this type of a trinomial? Perfect square, thank you. This is an x plus 7 squared equals 0, right? Now, let's say, how do I do this? How do I cancel this power of 2? Square root. So I got x plus 7 equals 0. Square root of 0 is 0. Subtract 7 on both sides. X equals negative 7. It only has one solution. Now, let's say that you didn't remember that. You didn't memorize it, which is a no-no, but let's just say you did. Or rather, you did not. X, what times what is 49, but when I do this, 14. Okay, now, this is where sometimes people get confused. Yeah, you're going to set x plus 7 equal to 0, but do you have to set both of them equal to 0 in this case? Why? It's the same thing. So x equals negative 7. So just so you know, this graph here, it's positive, so it would look something like this. Because it only hits one time. And remember we went through yesterday how it looks if there's one solution? Does that make sense so far, guys? Now your favorite, word problems. Okay. You were constructing a frame for a rectangular photo shown. If you've ever gone to framing stores, guys, people pay hundreds of dollars for frames. If you are a carpenter that makes frames, you're making a lot of money, okay? So anyways, if you do it correctly. You're constructing a frame for a rectangular photo shown. You want the frame to be the same width all the way around. So that's why I have a width of x all the way around. I want it the same width. You with me so far? And the total area, you want the total area of the frame and the photo to be 315 inches squared. What should the outer dimensions of the frame be? In other words, what is x? First of all, what's the area of a rectangle? Length times width. Not side squared. Side squared is for a square. Okay? Now, please pay attention. We're going to have a width and a length, correct? Right, guys? Okay. The width is from here to here. From this blue point to this blue point, how long is that? 17, right? You with me? It should be on your paper too, guys. 17. Okay, if it's not on your paper, write it down. 17 from the edge of the picture to the edge of the picture, that's 17. But am I not also adding an x and an x? So what is the real dimension of the width? Not L squared, Bubble. No. Let's do this again. From the border of the portrait to the other border of the portrait, that's 17 inches right there, right? And then, am I not adding 2 x's? Okay, I don't know where you're getting 17x squared from. The total width here is 2x plus 17. Why are you guys multiplying when you're adding it? Guys, what don't you see here? Okay, I think that you're choosing to make this more difficult than it is. Don't I have from here all the way to here? Don't I have an x? Yes or no? Plus 17? Yes or no?
Yes.
Plus another x. So what is the width? 2x plus 17. Do you guys see that?
Yes.
If you do not, raise your hand and I will help you. Okay, fine. Now, let's do the length. The length is from here to here. I have an x plus 11 plus an x. So what is my length? 2x plus 11. You guys with me so far? Okay, now, area equals length times width, correct? Don't they want the total area here to be 315? Well, isn't that going to equal length of 2x plus 11 times width of 2x plus 17? Yes or no, guys? You with me, guys? Okay. Now, what do I do here? No. You can't set this equal to 0 yet, sir. Thank you for thinking, and I'm proud of you. But you can't set this equal to 0 yet. Why? Oh, that was horrific what I just did there. Why can't you set this equal to 0 yet? You got to first multiply this. So this is 315 equals FOIL. 2 times 2x is going to be 4x squared plus 34x plus 22x plus 187. Then I'm going to subtract 315 to both sides because, yes, just like you said, my brother, you must set this to 0. So 0 is going to equal 4x squared plus 56x minus, you got 315 minus 187. That's 122, right? No. 122. Yeah, I borrowed from the fund. That's a 0. No, I did something wrong there. What's wrong with me, man? 315 minus 187. Come on, Moro. Bam. Sorry about that. That's 15. That was just a total lapse in judgment. 108. Right? Next. Oh my God, what is wrong with me today? Wow. I'm actually testing you guys and you got it. No, that's my fault. I'm being a doofus today. Okay, does that make sense so far? You with me? Are you sure you're with me? Okay. Come again? Okay. What can I do to make this easier? Factor out of 4, right? Or divide 4 to both sides. When I divide 4 to both sides, I'm going to get x squared plus 14x minus 32. What times what is 32, but when added together is 14? What times what is negative 32, but when added together is 14? Positive 16 and negative 2. So x is going to equal negative 16 or 2. Which one of these can be the only valid solution? How can it be negative 16? You can never have a negative distance. It can only be 2. X has to equal 2 inches. Does that make sense, boys? Are you sure? Homework is valid from Tuesday. It is the 9-4 homework. Yes, sir. Okay, the 4 I just factored out. If I would have had that 4 out here, if I had 4 times x plus 16 times x minus 2, let's say I didn't factor it out. I got to set 4 equal to 0. Is that possible? No. So you could just divide that out. Thank you, guys. Have a wonderful day. May God bless you. Thank you. Thank you.